And then lastly, the last one that we're going to look at today is the quadratic formula. You can use this for any quadratic equation. The key thing is to put it into standard form and then plug it in or substitute it in to the quadratic formula. So we have x squared plus 4x minus 6. So nothing multiplies into negative 6 and adds up to positive 4. So we can't factor it. B equals 4, so we can't use the square root property of equality because we need b to equal 0 in order to do that. So we're going to use the quadratic formula. This quadratic formula works with everything. The downside is that it does take some time and there's a lot of arithmetic involved. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, where a is the coefficient in front of the x squared, b is the coefficient in front of the x, and c is the integer as the last number. It doesn't have a variable with it. It's the constant. Okay, so let's substitute that in. So we get negative 4, because it's like negative b, so negative 4 plus or minus b squared, so 4 squared, minus 4, so the number 4 is always there. A is 1, there's an invisible 1 there. And then c is negative 6, all over 2a. So a is 1 again. So that's how we start off. We can then do some arithmetic. So negative 4 times 1 times negative 6 equals positive 24. And 4 squared is 16. So we get negative 4 plus or minus the square root of 40 over 2. We then know that the square root of 40 is the same thing as 2 radical 10. So we can simplify this radical to 2 radical 10. And then we can simplify this fraction to get to that x is equal to 2 plus or minus the square root of 10. So that's our solution, that x equals 2 plus or minus the square root of 10. So x equals 2 plus radical 10, and it also equals 2 minus radical 10. So now let's apply this to geometry. A regular polygon has 2 known angles. Find what type of polygon it is. All right, so we know that this is a regular polygon, and regular polygons are equilateral and equiangular. So therefore, we know that these 2 angles are congruent. We may not know what the measures of these angles are, but we know that they are congruent. So I said 15 times the quantity of x squared minus 8 equals 15 times the quantity of negative 2x. I then did the division property of equality and divided both sides by 15 to get that x squared minus 8 equals negative 2x. I then added 2x on both sides, the addition property of equality, to get everything over on one side. So we have x squared plus 2x minus 8 equals 0. This time, while you can factor, because I wanted to keep the numbers nice, we're going to use the quadratic formula. So in this case, please tell me what A, B, and C are in this quadratic equation. So A equals 1, B equals 2, and C equals negative 8. So that's what we can do. So negative 2, because it's negative b, plus or minus, so b squared is 2 squared, minus 4a is 1, c is negative 8, all over 2a, and a is 1. We can then simplify. So go ahead and simplify if you didn't happen to see the next page. And it turns out that x equals 2 and x equals negative 4. So what we can do from there is we can substitute 2 and -4 in for x to find the measure of a single interior angle of this polygon. So when x equals 2, so I'm picking this one to check it with because the numbers are a little bit nicer. So when x equals 2, -2 times 2 is -4, and 15 times -4 is -60. Well, it's impossible in geometry to have a negative angle in a polygon, so that's not going to work. But when x equals -4, the measure of the interior angle is 120 degrees. 15 times -2 times -4, or 15 times 8, is 120. So now we know that the measure of each of these interior angles is 120 degrees. So 120, 120. So now we know that. How do we find what type of polygon this is? So we know that how we find the equation, how we find the measure of a single interior angle of a regular polygon is that we take the sum of a regular polygon or of the polygon and divide it by the number of sides or the number of angles. So we'll do n minus 2 times 180 divided by n. And that's going to equal 120 because we know that each interior angle is 120 degrees. So how do we do this? We're going to cross multiply. So we kind of like make it 120 into 120 over 1. We multiply 120 and n, and we multiply 1 times n minus 2 times 180. I then distributed out the 180. So I did 180 times n and 180 times -2. So that now I get 120n equals 180n minus 360. Another thing that you could do is that you could multiply both sides by n and then distribute the 180. So from here, I am going to subtract 120n on both sides to get n by itself and add 360 to both sides. And then finally, divide by 60 and n equals 6. It is a hexagon. So in review, there are 3 ways that we've reviewed to solve quadratic equations to find out what the x is when we have an exponent of 2. And so we could use the square root property of equality, we can factor, and we can use the quadratic formula. And then we can apply these to the geometric equations that we've learned in this unit. So the sum of the interior angles, the sum of the exterior angles, and finding a single interior angle of a regular polygon. All right, go on and take there are 2 quizzes. 6.3a quiz is about, it has algebra, so it doesn't have any quadratics in it, but you're applying all the polygon equations with algebra. And then the second 6.3b is about quadratics. So you're but you are going to be solving quadratics in these 3 main ways. Good luck and have a good one. Bye-bye.